Okay, 3.3 Part C. Never had a Part C to a lesson before. Now is just going to be no new information, it's just applying it to some contexts, making sure you can use it appropriately in certain contexts. So consider the following quadratic in vertex form. So basically, when you see vertex form, can we solve word problems with vertex form? This equation shows that there's a minimum value of, well, the vertex is 216. And it is opening up, so it will be a minimum value, and the minimum value of 16 is the lowest it's going to be when x equals 2. So those are the things we know about it, and the vertex is very important for word problems because every time it's a maximization problem, we're always looking for the vertex to solve. Vertex comes up in all sorts of different ways. So let's look at some of these. Basically, we're going to be starting with the end, and then we're going to be going right to the complete word problem and trying to solve the whole word problem from scratch. So the very last step we're going to get to at the word problem is going to look like these questions. I'll try the first one, then you probably should pause this and try a couple on your own as well. So the following equation shows a relationship between the height and the time that has elapsed. So it actually doesn't say in meters and in seconds. It says units, but it only has x and y here. So I'm assuming y is the height and x is the time. That's usually how these go for quadratics because it's like a ball falling according to time. So time's usually the x value. So this relationship shows a what? It shows a maximum height. It's opening down. You should be able to kind of picture this. It's got a vertex at 840. It's got something like that. So this shows a maximum of 40 when, let's do actual units here. So maximum of 40 meters, a max height of 40 meters when time is equal to 8 seconds. That's pretty much all we're doing, is just analyzing the vertex, making it make sense in relation to the word problem. So if you think you can try the rest of these, pause it, or maybe I'll do one more. The following equation shows the relationship between the area of a rectangle and its length. So its length is the thing that's changing, that's the independent variable, that's length, and the area is going to be the thing that you're measuring. So this relationship shows what's the vertex? Let's pull the vertex out, that's 5, 15. You should be really good at recognizing this opposite for the x value. By now we've been doing this in every single section so far. So this relationship shows it's opening down, so a maximum. A maximum what? Maximum area of 15 meters squared. When the length is equal to 5 meters. If the length of the rectangle were 5 meters, then you'd have a maximum area for the rectangle of 15 meters squared. This will make sense when we see the whole word problem. Basically, if you have a finite amount of building material, then you'd want to set the length in this particular situation to 5. And then the width would be whatever you have left. I don't know the actual context here, but something like that. The following equation shows a relationship between the vertical height of a golf ball, again that's going to be the y, and its horizontal distance traveled. So the horizontal sometimes is time and sometimes it's distance traveled. It works both ways. So it could be how long it's been in the air, or it could be how far it's traveled sideways if it's like a cannon shot or something. So this is distance traveled. What's the vertex? It's at 30, 10. So this is a very shallow one, looks like. Actually, -5, it's pretty steep. In the real world, these are always going to be, at least in my experience, the a value, this is just what we use in math class. Usually in the real world, it's like -0.0048 or something. This relationship shows a maximum height of 10 meters at a distance of 30 meters. From what? Does it say? From the origin, from when it was hit or something. Yeah, it doesn't say what 0 represents, but I assume it's where the person hit the golf ball. The following equation, let's try and do it without as much fanfare. Let's see if we can do it nice and quick. Shows a relationship between cost and number of sweaters ordered. So the vertex is 10, 200. So a max cost, it's going down. Most of these seem to be maximums, right? I think that's definitely more common. It's not going to be everyone, but it's definitely more common in word problems to have negative values of $200 when number of ordered, when 10 sweaters ordered. The following equation shows a relationship between Amy's mark on a test and the number of hours she spent studying. Ooh, nice. I wonder why it's a quadratic. So it's a quadratic opening down. So after she spent 15 hours, she's going to be at her best mark on the test, which is 25. Ouch. Yeah, there's no other way to read that. That's not a very good mark. At 0, I don't know what it's going to be at 0, but it's going to be some kind of parabola like that. So her ideal amount of time studying is 15 hours. Doesn't seem like a very realistic equation. But this relationship shows a max mark of 25% when she studied for 15 hours. So that's our last step. Always you need to, we're not just going into vertex form for no reason, we're going into vertex form to be able to analyze some kind of relationship and find some kind of answer to our word problem. So it's a very clear purpose. And by the time we're done quadratics, we're not going to tell you to go into vertex form. You're going to have to look at what we're asking you for, find out if it's the vertex we're asking you for, and then decide that you need to go into vertex form. So you're going to have to be prepared for that. I think we only have a couple of questions to do in this one. All word problems, so they take a little bit longer than usual though. Example number 1. Why don't we read this first? So far when solving problems, we've used graphing to determine the vertex and therefore the maximum or minimum value. Determining the maximum value by completing the square can be faster and more efficient. As soon as you're good with it, it definitely is. And maybe especially, unfortunately, when you're in math class, because then we make the numbers work out nicely. In the real world, maybe it doesn't always work out as nicely. Maybe it's better to, probably the fastest way would be to use Desmos, actually, which is what I go to for my fastest way. But we're mathematicians, and we need to be able to do it with complete the square. A bit too much honesty from a math teacher. Two numbers have a sum of 20. Does the sum of their squares have a maximum or minimum value? Determine the value and the two numbers. So there's actually 3 things we don't know. We don't know our first number, x. We don't know our second number, y. And we also don't know the sum of their squares. Let's call that capital S. Usually y values we capitalize, and our inputs, our independent values, we keep lowercase. So there's actually 3 things we don't know. We need to write 2 different equations. Equation number 1, the sum of the 2 squares is 20. X plus y is 20. There's only so many different types of word problems. The ones with numbers usually start like this, 2 different equations. The sum of their squares, so if you did x squared plus y squared, that's got to equal some sum. We don't have a number there. You guys are probably used to seeing a number there. This is the number that we're going to want to use as our y value eventually. So this is going to be the thing we're looking for, either a maximum or a minimum of. So how do we actually do that? Well, we can't do anything with 3 different variables. We don't know how to graph with 3 variables. There is a way to do it. You can add an extra axes, but let's not worry about that. What we want to do is simplify. Since we have two equations, we want to simplify 1 and sub it into 2. So 1 actually says x is equal to negative y plus 20. So just rearranging for x, now we sub that into 2. Sub into 2. So instead of x, I write that. So negative y plus 20 squared plus y squared equals s. Good. We have an equation. This is starting to look like our parabola. Only problem is it's all kind of complicated right now. We've got a y squared kind of over here with a binomial. We've got a y squared here. We need to expand and turn this into standard form first. Standard form is just the cleanest one to kind of start with. So let's expand this. Negative y squared, negative y plus 20 times negative y plus 20 plus y squared equals s. So negative y times negative y is positive y squared. Positive 20 times positive 20 is positive 400. Is that right? 400. And now negative 20y minus 20y is negative 40y plus our original y squared equals s. So just FOIL it out and now collect like terms. So why don't we rearrange so s is on the other side, because that's what we're used to seeing. 2y squared minus 40y plus 400. Okay. Now we want to know whether it's a maximum or minimum value. Well, we already know it opens up, so we already know it's a minimum. We don't know what that minimum is right now. It's not 400. It's not negative 400. We need to actually solve this into vertex form to be able to know that. So let's do that. I think we have enough space. It only takes 3 lines, right? Throw out the 400, common factor the 2. We leave y squared minus, divided by 2, minus 20y. Negative 20 divided by 2, negative 10 squared is positive 100. Should have left more room in my brackets. Well, that's fine. And kick out the negative 100. So equals 2, y minus 10 squared. 2 times negative 100 is negative 200 plus 400, which equals 2 y minus 10 squared plus 200. So it is a minimum value of 200. The minimum sum of the squares is going to be 200. That's the smallest sum of the squares that you could possibly get. Pretty interesting, right? And that happens when y, so this one's a little bit hard to figure out. That's why I do like to pull out the vertex. So in this case, the vertex is 10, 200. Now this is usually xy, but in this equation it is not xy. In this equation, our y value is actually s. So the 200 is the minimum sum. That's right? Yeah, opening up. And the x value is actually our y. So it's a y value of 10. So when y equals 10 is what we solved for. It also wants to know the x value, just like before, what you were doing last year. Sub it back into one of the equations. We can sub it into this one. If y is 10, x has to be 10. So we solved for all 3 things. Good. You try. Pause it here. This might take a little while, but you should try it on your own first. Don't just keep playing the video straight through. Alright, 2 numbers have a difference of 18. So x minus y equals 18. Should start further to the left so I have room for multiple things. Does their product xy is a product, and that is some kind of product P. Does their product have a maximum or minimum value? So let's solve number 1. X is equal to 18 plus y. Sub that into 2. So instead of x, we write 18 plus y times y. Expand this out, so it's a y squared plus 18y. I'll throw my p on the other side for clarity. So we know it opens up, so it's going to be a minimum value. Let's complete the square. This one's actually going to be really, really easy to complete the square. We have no a value, so actually all we need to do is find what that c value is going to be. The c value we're looking for, 18 divided by 2 is 9, squared is 81. So our -1 can just go out immediately. There's nothing special about it because there's no a value. It just can get tossed out after the fact. So our vertex form is y plus 9 squared minus 81. So our vertex is at -9, -81. So what does that mean? That means there's a minimum value because a is positive, so it opens up. So min value of -81. The smallest product you could ever come up with is -81. And that's going to happen when you have a y value of -9. What's the x value have to be? Well, if y is -9, x minus -9 is x plus 9. So subtract 9, x also has to be positive 9. Or you could have used this one. Some of you might have done that and figured out it has to multiply to -81. Anyway, -9, positive 9 is going to be the smallest possible one. Okay. The perimeter of a rectangle. Is this the last question? Oh no, there's a couple more. A few more. This is another one of our number ones with perimeters or with x and y. The perimeter of a rectangle. Geometry is actually a little bit clearer. I like these ones a bit more. Perimeter of a rectangle is 32 centimeters. Determine the dimensions that produce the maximum area. I like these ones quite a bit. Always start with a picture. So it has to be a rectangle, which means we have an x here, we have a y here, and we have two formulas. The perimeter is equal to 2x plus 2y, and we know the perimeter is 32, so 32 is equal to 2x plus 2y. That's equation number 1. Equation number 2, you want the maximum area. You want the area to be a max. So number 2, the area is equal to x times y. This is just like the last question, right? So what we did in the last question comes up when we're talking about perimeter versus area. There's no restrictions on this, so we should be able to tell that it should be a square. So whatever 32 divided by 4 is, which is 8. We kind of know that x is equal to 8, y is equal to 8. We already know what the answer is going to be if we're at all observant. And you will be able to tell that when we get questions like this on the test. But sometimes we do restrictions, like if you have to have the short length like 4 times or something, and the wide length only twice. What should the dimensions be to maximize the area then? So there's lots of different ways you can play with these two formulas, but you'll see a lot of questions like this. This is just the simplest possible one. So don't rely off of just knowing it's got to be a square. Let's actually solve it using our quadratics. So first thing we need to do is solve number 1 for one of the variables. So in question number 1, let's solve for y this time. We haven't done that before. So we would say 2y is equal to 32 minus 2x. Divide by 2. y is equal to 16 minus x. Divide both terms by 2. Now we sub that in. So area is equal to x times 16 minus x, which is equal to negative x squared plus 16x. So that's not too bad. Now we need to complete the square again, and there's no c value, so it's going to be not too hard, but we do have an a value, so we have to common factor the negative out. Which turns that one negative. 16 divided by 2 is 8. Squared is 64. Plus 64 minus 64. I don't mind, in fact I probably encourage you to always write that step out. So say c star is equal to b over 2 squared, which is equal to negative 16 over 2 squared, which is equal to 64. It's actually, I probably would want that. I can do it. I've done like a million of these in my lifetime, so I can do them pretty good in my head, but it might be good to always write this step out just so you're not ever getting confused. Now we gotta get rid of the negative 64. When it moves outside, it just becomes positive 64 because of the negative. So x minus 8 squared is what's on the inside, and positive 64 is what's on the outside. So we have a vertex of 8, 64. So what does that mean? Determine the dimensions. Always be careful what the question is. We don't actually need to know what the area is in this question. So we know the x value has to be 8. So what is the y value? You can sub that into either equation. Let's sub it into 1. So 32 is equal to 2 times 8 plus 2y. 32 is equal to 16 plus 2y. So 16 is equal to 2y. So y is equal to 8. So indeed, x is 8 and y is 8. You can double circle them. This one you might want to write the dimensions are. So therefore the dimensions are x equals 8 and y equals 8, or a width of 8 and a length of 8 centimeters units. Good. I should write centimeters in here. At least that. And yeah, I would write a so therefore sentence for the word problem. Okay, you try another one with perimeter. Is it also area? Where the dimensions of the largest possible garden? Yeah, perimeter area question. A perimeter area question. So pause it, try it on your own. So this one, again, there's no extra restrictions. It just has to be any kind of a rectangle. X, Y, where x, 2x plus 2y has to equal 100. You have 100 meters of fencing. So what should they be? And we actually know right now it's going to be 25 by 25 because there's no extra restrictions on this one. But let's solve it again. Number 2, area is equal to x times y. So solving number 1, it's actually almost the exact same equation. So you're going to be subtracting 2y, dividing by 2, so negative y plus 50. You should be able to get to that pretty quickly. I know I'm not showing the steps for this one, but it's just like the last one. Now sub that into a, sub into 2. A is equal to negative y plus 50 times y, which is negative y squared plus 50y, which is equal to, so there's our standard form now. We've expanded it out. Now common factor the negative 1. find the new C value. So C star is equal to 50 over 2 squared. And what is 25 squared? 225, 625. Plus 625 minus 625 equals negative y plus 25. Am I doing that right? Yeah. Squared. Oh, I'm not. I made a mistake. Did you guys catch my mistake? There's a nice little bonus question for you. Somewhere in these lines there's a mistake. Okay, hopefully you had enough chance to look. I common factored out the -1 where right here, but I didn't actually common factor it out correctly. The sign of this one should have changed to -50. It still makes it 625 as my new C value. Still makes that -625, but that means this has to be -25, which is where I saw the mistake because our X value or Y value needs to be +25, which is what that'll be now. We kick out this 625 and it becomes positive. So negative times -1 makes positive 625. So what are the dimensions? So y is equal to 25, and you can sub that back in here and you'll find out x also is equal to 25 meters. So therefore, the largest possible garden is length and width of 25 meters in this example. So there's that one. It didn't actually ask you how big the garden's going to be. That's what this number is. This is actually the area. If you're pulling out the vertex, this 25 becomes the y value, and this 625 becomes the area. So the biggest garden you could actually produce is 625 meters squared. But it didn't ask us that, so we didn't need to write it down. Example number 3. So another type now, and then I think we have one more year try. So 3 different types of questions. This will end up being a slightly long video. A student parking pass costs $20. At this price, 150 students will purchase passes. For every $5 increase in price, 20 fewer students will purchase passes. I was just doing these ones with Haley in calculus, so don't forget these types of examples. You'll see them next year. So we need 2 types. I actually like to write this. This one actually doesn't require 2 different equations right from the get-go. You can get it right down to 1 equation right away. I like to write out where we start. So this is kind of a, I don't know what we'd call these ones. Trying to find a price point, maybe we'll call it. So there's some kind of, you can sell so many passes and you can make so much money. And there's a certain amount of price increases, so you make the tickets more expensive and then you make more money, but then you keep making it more expensive and you sell so much less, then you end up making less money. So there's some kind of sweet spot that we're looking for in this graph. How many times should you increase the price? So the first thing I do is just write out what you are at the beginning. So the parking pass costs $20 and 150 people would buy it. So 20 times 150 equals $3,000. So at the very beginning you're making $3,000. That's right here. Right there, that's 3,000 high. And I'm assuming that's not going to be the best option. So now we need to define a variable. For every $5 price increase, 20 fewer students will purchase passes. So let X be the number of $5 price increases. let x be the number of times you've increased the price by $5. So now we only have a single variable, and that will represent every single point along this line, as long as we change both of our numbers by that variable. So 20 was how much it costs. Instead of 20, it's now going to be 20 plus 5x. The amount of cost is 20 plus $5 for every price increase. So remember, x is just the number of price increases. It's not the amount of the ticket or anything. The amount of students that are buying it is 150. But now you're going to lose 20 every time you have an x. Minus 20 times whatever your x is equals your total profit, let's say. So the profit is now variable, but this should be an equation to model how much money you're going to make. So some people always ask at the beginning of quadratics, what the heck is a quadratic good for? Here's one example. If you're trying to model it, trying to find the right price point for a product, it will actually be a parabola, and there is actually a sweet spot, a vertex. So this is factored form. This is an even factored form. This is just some kind of weird, it looks a little bit like factored form. This is not in proper form for factored form. So you can't actually find the roots from this form. Well, you could a little bit actually. If you set each of these to 0, you could find where the roots are. But we don't care about that. So we need to get this into vertex form is what we're actually looking for. You could graph it right away with your graphing calculators. You could plug all this in and it will produce a graph, and maybe you could read the vertex from the graph. But if it's going to be some kind of decimal answer, maybe you can't. Well, your graphing calculator can probably calculate it. Well, let's expand it. So 20 times 150. Nice and slow. This is going to be a harder FOIL than usual. So 150 times 20 is equal to 3,000. 20 times negative 20x is negative 400x. So that's that one, that's that one. 5 times 150 is equal to 750x. And here's where the quadratic comes from, an x times an x. So 5 times negative 20 is negative 100x squared. Okay, let's tidy that up a bit. So the profit is negative 100x squared. These two terms combine to 4, 5, 6, 7, positive 350. X plus 3,000, sorry. So there's our standard form now, and now we need to complete the square. They look like nice round numbers, so maybe it won't be too hard, but it definitely isn't going to be a super easy one. We need to common factor our a value and everything. So the next line, common factor the negative 100 every single time. That leaves an x squared, leave a lot of gap. We have our 3,000 floating around at the back. That's how I start these every single time. Now what is 350 divided by negative 100? Well, that should be negative 3.5. Yes, in this one I'm going to do decimals. I'm not going to worry about fractions. 35 over 10. No, I'm just going to do decimals. It's context of money anyway, so we would only need to round to 2 decimal places in this case. What is the C star value I'm looking for? So C star is equal to negative 3.5 divided by 2 squared. This is going to be much nicer as a decimal than it will be to do as a fraction. 3.0625, if I did that correctly. So plus 3.0625 minus 3.0625. And we got to get rid of that one. So next line, I complete the square and get rid of that guy. So negative 100 in the front. Inside, it's going to be x minus half of that. What is that? 3.5 minus 1.75 squared. Negative that times that, so actually just move the decimal place twice and change the sign. So it should be positive 306.25 plus 3,000, which equals negative 100. X minus 1.75 squared plus 306.25. Okay, we have our vertex. That is 1.75, 306.25. Now, this one is a little bit longer to analyze. You need to be really careful when you're analyzing it. We actually have two questions. What is the price of a parking pass that will maximize the revenue? This is actually going to be the harder question to answer. So let's try and answer A first. We know this is X and this is P in our vertex. That's always the X value, that's always the P value of the vertex. So our profit, this is actually going to be the answer to B. The maximum revenue is going to be $3,306.25. What does this represent, though? We're not going to be selling parking passes for $1.75. This is the number of $5 price increases. So how much has the price actually gone up by? 5 times 1.75 is $8.75. So we've actually increased the price by $8.75. And the price started at 20. So the price for the max value parking pass is going to be $8.75 plus 20 is $28.75. That's how much you want to charge for a parking pass. Then the answer to B, how much money will you make? Max profit of $3,306.25. Hopefully you write that in a bit more formal of a sentence than just that. Maybe an extra 2 or 3 words. That's pretty much all you need, though. The maximum profit you could earn is, or the maximum revenue, I guess. Revenue and profit are 2 different things, but I don't want to get into that right now. Okay, last question. You should pause this video. I know we're only 38 minutes in. That's not too bad. You should pause this video. Try this one on your own first. When you unpause, I'm just going to solve it without talking, and hopefully you can follow along. If you need me to explain it to you, come back to the classroom and I'll explain to you. Okay. I assume you tried it now. Okay, there's that problem. So you should be able to write the equation. These ones are a little bit challenging, but with some practice, they always kind of look like this. Expand it into standard form, turn it into vertex form, identify the vertex, and then also interpret the vertex. And this part can be a little bit hard to interpret. The number of 10-cent increases is 2.5 of them, so it went up by 25 cents. So it goes to $1.75. Okay, try the worksheet.